Hello, everyone. Welcome to ET 232. This is Dr. Hamidi Salzadeh. Um, I got several requests from students that they wanted to see a video or recorded video for the midterm. Even though I have a solution for midterm, so I decided to do record a video. So if you got any questions, so you can refer to this video, and also you have further question, please do not hesitate, come to my office, send me email, then I'll answer your questions. So in the midterm we had four problems. The problem one was this picture where we had to find the resultant force um, from based on these two forces. We have two forces. One is 150 kips. The other one is 100 kips. Correct. But the method, we ask in the question. Please check your, midterm problem one. In the description, it says use triangle method, not the other method. So you have to use this method. This method, I specifically ask because some of the problem later on in the static, you need to use this method. Otherwise you want to use x and y. It's gonna be very difficult. That's why we want a student to be familiar with this technique throughout the semester. So this method is what we do. We use tip to tail of the vectors, right? We have two vectors, as you see here. This is one. This is the second one. So if we draw, we just transfer the first one, something like this one, right? I just transferred it. Let me, make it more realistic. So it's gonna be 30 degree with horizontal line, right? So again, that's more than 30. I think this looks better. Um, Nothing happened. I just transferred that, vector, which is 150. And the angle with the horizontal line is 30 degree, right? So this is 150 and the angle is 30 degree. What else? We have another vector, 100. So the method is tip to tail. So tip of this one, the first one goes to the tail of the second one. So it's gonna be like that. So I just translate, I just carry, vector 2 to the tip of the vector 1, right? Nothing happened. So the rotation, it's gonna be the same, as you see here, we have 50 degree angle, so it should have 50 degree angle with a vertical line. I have to have that one here. Okay. What is the next part? The next part is to draw um, uh, the resultant force. Resultant force start from the tail of the first one, goes to the tip of the second one. This is R, right? So we have the triangle now. What we do, we need to use the those tools I mentioned in the class to find the magnitude and the angle of R with a horizontal line. So here we know that the first the first vector is has a 30 degree with horizontal. So if we draw a horizontal line, right, and then draw a vertical line, so this is gonna be 90 degree, right? Well, how about this one? This one will be, this is a right triangle, correct? This will be so 30 plus 90 degree plus what angle? It's gonna be 180. So interior of the triangle has to be 180. Theta should be 60 degree, right? This should be 60 degree. So we have that one. And you know from here, so this portion from here all the way, it should be 180 degree, right? And then, and we have the 60 degree in this portion and 50 degree in this portion. What do we have in the middle? The middle is gonna be 70 degree, right? So now in the triangle we have, this angle, and we want to find this r. So r, then we can use the cosine law, right? R is going to be the square root of um, these two sides, 150, the square root, to the power of 2. Then the other one um, is 100, right? Plus 100 to the power 2 minus 2 times 100 times 150. I think my solution, I forgot to use 150. So then multiply by cosine 70 degree. The r will be 149.12. Okay, so this is one. The next one is to calculate the angle. What is this angle? We need to find this portion. So we have this, this 30. Now we need, this portion, theta, right? So we use the sine law, right? Sine equation, which is, r. Let me use the same color, black color here. R divided by sine 70 equal, I'm gonna use, find theta, so I should use that 100, right? That side, sine theta. So at this point, we just cross them, multiplication, r times r, we have it, which is 149 times 12. Let me use the black color here. 149.12 times sine theta, 100 times sine 70. So you can divide 100 times sine theta by 149.12. Sine theta is sine 70 divided by 149.12. Okay, let me move this one. Then, so we find this ratio, theta will be inverse sine of this ratio, 100, sine 149.12, which is 60, 39 0.06 degree, right? So this is my theta. but I'm not done yet. I have to add it to 30 degree. So alpha will be theta plus 30 degree. Then it will give me 69. So this is my final. So that shows the angle between R and this horizontal line. Okay. So we'll go to the next problem.